All right, guys, so 7.4 starts the second half of this chapter. So up till this point, we've learned about adding and subtracting polynomials, all right? And we've been multiplying binomials, and we've been learning about some shortcuts with special products. Well, what we're going to do next is the opposite of that. Instead of multiplying, we're going to divide and try and break things down. So factoring, today we're going to be talking about GCF and factoring. Factoring is a mathematical task of breaking down an expression into its pieces, its factors, its multipliers. GCF stands for the greatest common factor. Way back in elementary school, you determined the GCF for 9, 12, or 15 and 40, or 16, 32, etc. Now we're throwing in some variables at you, okay? So let's just go over a couple things, all right? Let's just say, for the heck of it, that we're looking for the GCF between 16 and 32. Get this up. Why is this not working? Oh, man. So let's just pretend for the heck of it, we're looking for the GCF between 16 and 32, all right? In elementary school, or maybe 6th grade, 5th grade, you guys were taught that you could list the factors of 16 out. So 1 times 16 is 16. 2 times 8 is 16. 3 won't work, but 4 times 4 is 16. There are your factors. 32, we have 1 and 32. We have 2 and 16. 3 won't work, but 4 and 8. 5, 6, 7. Okay, so I see between these numbers, their greatest common factor is 8. So now what we're going to do is look at these monomials and decide, hey, what's their greatest common factor? So when I have 24jk and 32j, I know that these both are even numbers. So I know I can take 2 out of them. I know I can take 4 out of both 24 and 32. 6 won't work. 8. 8 is going to be the GCF they have in common, the greatest common factor. Well, they also are going to have a j in them, right? So 8j is going to be my greatest common factor because they both share a j. I can pull out 8j from both of these and simplify their expressions. For 2, my greatest common factor between 10 and 25 is 5, and they both share x. So I can pull out a 5x. For 3, 14 and 17, well, 14, I know we have 1, 2, 7, and 4. 17 is prime though. So that means I can only pull out a 1 from those numbers. Look at my x's. I have x cubed and x to the 5th. So instead of just saying x for this one, they both share multiple x's. So they can share 3 x's. Those can come out when I factor. And when I factor out y, I have y to the 9th and y to the 17th. They share 9 y's as well that I can factor out. So greatest common factor is figuring out what they have in common that we can pull out together, okay? Factor out the GCF from each polynomial. So when I look at this, find the GCF. For me, I'm seeing 12t. That's great. I pulled out 12t, but now they want to know what's left. And I'm going to leave what's left in parentheses. So since I pulled 12t out of 48, I know I'll have 4t left. And then I pulled out a 12t here, so negative 12t divided by 12t is just negative 1. Okay, number 2, I have 5, 9, and 15. Well, I know 5 can come out of 15. I know 3 can come out of 9 and 15. But as far as 5, 9, and 15, they only share 1. They also share x's, but they only share 1x because this x is just the first power. So what I'm going to do now is say what's left. Well, I have 5x minus 9 plus 15x to the 3rd. When I pull out 1x from that, I have 15x to the 2nd power. Okay, down below, when I look at this one, I see 4 terms. All right, looks like 5 for these first 2, but then we see some 3. All right, this is going to be prime. If you cannot pull anything out of your expression, it's prime. Number 4, I see I have 3, 9, and 6. So I know my GCF between those is 3. I have x to the 2nd, x, and x, so I can pull 1x out. And they all share y. I can pull out 1y. Okay, as I go through, that means I am left with 2, because 3 times 2 gives me 6, x, there is no y in this term, minus 3, because I pulled the xy out, plus, when I pull out 3xy, I'm just left with y. So here is my factored polynomial. Or sorry, my GCF pulled out of the polynomial. All right, so that is pretty simple, 7.4 GCF factoring our polynomials.